be working a thermodynamics question from thermodynamics approach, and it is on chapter 5 of the 5th edition, and the question reads: steam is to be condensed in a condenser of a steam power plant at a temperature of 50 degrees Celsius with cooling water from a nearby lake, which enters the condenser at 18 degrees Celsius at 101 kilogram per second and leaves at 27 degrees Celsius. Determine the rate of condensation of the steam in the condenser. Well, the first step to take when working out these problems is to always write your thermodynamic law equation, which simply states, well, I'm going to make it simpler and split it in two. So I'll write one for the steam, and I will write another one for the lake water. Okay, and for the steam, well, let's first write the equation. So you have Q dot minus W dot equal to M dot H2 minus H1, bracket that, plus V2 square minus V1 squared over 2 plus G Z2 minus Z1. Now, the first thing to know, the first equation, is that there is no work being done, so that term is gone, and the condenser, the speed is negligible, and also the height. So all these three factors go to 0. And for the lake water, which would be Q, well, we're going to call these Q for the steam S, and for the lake water L. Q dot minus W dot equal to M dot. Let me just put on the proper subscripts, and H2 minus H1 plus V2 squared minus V1 squared over 2 plus G Z2 minus Z1. And once again, the work term is gone, as well as the velocity term and the potential energy term. So, first of all, we're going to take the equation for the steam, and that is going to give us Q dot S is equal to minus M S dot times H2 minus H1 is equal to minus M dot times HF minus HG, which is equal to minus M dot HFG. And the reason for this is because phase change occurs at constant temperature, and as it says in the question, this takes place at 50 degrees Celsius, and the steam entering must be at saturated vapor for condensation for condensation to take place. Okay, and for the lake water, Q dot L is equal to ML dot times H2 minus H1 equal to M dot L CL times T2 minus T1, and CL here is the specific heat of liquid water. And okay then, and from our saturation tables, from saturated water tables at 50 degrees Celsius. HFG is equal to 2382 kilojoules per kilogram. Okay, so now the next thing that we're gonna do here is to equate the two, being that energy is being transferred from one to the other, which means the steam is losing energy to the lake water, which simply means QS is equal to QL. Therefore, and since QS is equal to minus m dot HFG, then m dot S HFG is equal to, and QL is equal to m dot L C2 T2 minus T1, then m dot L CL times T2 minus T1, and you just plug all that you're given into the formula, and this equation will be m dot S is equal to 101 times 4.18 times 27 minus 18 all over 2382. Now, as you can see here, the specific heat of water is 4.18, and it doesn't matter if you change from Celsius to Kelvin because the difference is the same. And so when you work this out, you find that m dot S is equal to 1.6 kilograms per second, and that is it. Now I'll run through it once more. As you can see right here, the steam is losing water, so that term is a minus. There's no work involved, no change in velocity or height, so these three terms go to zero. Similar case for the water. The work term, the kinetic energy and potential energy terms go to zero. Then, being it that the water is condensed, that means the steam enters at saturated vapor. So this formula breaks down to minus m dot times h sub fg. And for the lake water, you can simply equate m dot L H2 minus H1 to m dot L C2 times T2 minus T1, and you equate both of them, meaning that they're both interacting with each other in a condenser, and simplify, and that will give you your answer.